This next recording will pick up with our animation in 3D in MATLAB. In the previous animation, we saw the STL read. We pulled in an STL file that we created in CAD, just an arbitrary STL file. We read it in. That imported the vertices and faces. We added to it other options such as face color, edge color. There are many options. Frankly, you should be able to recreate the exact same level of rendering that you get out of your CAD program in MATLAB. That just requires you spending lots of time looking at the patch and all the coloring. For example, there's camera viewpoint, there's lighting, there's shading options. There's a lot of detail here. I will be doing very trivial red, white, blue coloring schemes, but know that that's out there. To draw the box, we create a figure, we patch the box. By default, patch recognize the faces and vertices from the structure. We created a set of axes that were fixed to make everything stay fixed. And in this case, we actually labeled the axes and gave it a P3. Now in this next demonstration, we want to look at add the animation to the plotting routine. So how are we going to animate the box? Well, the way we animate the box is we come back here. Let's say we want to make the box move this way. Well, to do that, I need to first draw it in this position, pause for a brief period of time, maybe 1/30th of a second, and then I'm going to move all my vertices slightly. All my vertices are going to move slightly, some small amount. Then, once I've moved all these vertices, I can draw the box again at the new location, hold it on the screen for a short period of time, and repeat the process. So really, I'll have a series of stills that your eye will render into a nice clean motion. I'll have to determine the rate at which I draw each of these stills and the amount that I move them each time to determine the visible velocity that I see on the screen. To reconstruct to run the patch command, I need the vertices and faces. The faces never change. The vertices, of course, define the position. So when I do a motion on the vertices, in this case I talked about translation, I need to preserve the rigid body properties. It's not a big deal for translations. For rotation, similarly, if I were to rotate the box, let's say I'm going to rotate the box around, let's say the z-axis here, located in the corner. I need to rotate all those vertices and I need to preserve the rigid body operation. So that means I need to use a special type of operator, an SO3 operator, which we knew is specific to preserve those operations. We call it the rotation, and we always define the rotation as the projection of the new frame onto the old frame. So that's what we're going to do now in our model. So let's do two things. Let's first do a translation and show it. And then we'll do a rotation and show that. We'll combine them. So our first motion, now we're going to go into the animate the box. To animate the box, I'm going to have first, so the motion will consist of first translation of 10 units along the X, then 90 degrees followed by 90 degrees rotation around the Z. So I'll do that in two steps. So first I'll do the translation. So to do the translation, I'm going to create a for loop. So I can do this in a couple ways. Let's I'm going to show you really have many ways. I'm going to show a method, well, let's start off with it simple. So we'll translate by some distance d, let's call it dx. So our dx is going to go from 0 to 10, and it's going to go in steps of 0.1. Now I have to move all the vertices. So if you recall, our vertice array was an n by 3, okay? So I need to go through I need to now step through each vertice. So, okay, so by the way, this was my This is how much, this is the move, the desired translation here, right? Next, I need to translate each vertex. So I'm going to go for I equal 1 to the length of box dot vertices, and I want the length of all columns row, oh excuse me, all rows column 1, for example. That should give me the length of that. Then inside there, I'm going to say box dot vertices, and I'm just going to here's what I'm going to do. I'm going to make that current one. I'm going to make it work from an original case since this is not a delta. So I'm going to jump up above. I'm going to create an initial box. I'm going to say box sub O is box. So I've just created an undisplaced original version. And in this case, I'll keep acting on the original version. So the current box.vertice row I all columns equals the original box sub O dot vertices row I all columns. Oh, but that's not a translation. Plus my translation, which will be dx, comma 0 in the y, and then 0 in the z. So that should pull out fine. I'll end that. Next, so there I've moved all the vertices are at the new position. So now I'm ready to draw the box. So let's pull this up. Ready to draw the box. I'm going to set my view 3. I won't worry about labeling the axes. I will define the figure number right at the beginning, and let's clear the axes. Now, patch is kind of weird. I don't know that we'll see what it does. We'll define the figure and clear the axes before we start the first time. Okay, so inside here we go through our desired translation, set that loop up, then we set a loop where we move every vertex, and we're ready to draw the box. Finally, we need to do a short pause. Let's let that pause be like 0.1 tenth of a second, or even a little less, and then we'll end. By the way, MATLAB time here is not real. I don't find that it's all that close to real time. You can play with that some and make a decision for yourself. So that's the translation. So, and we've ended the translation move. So let's give that a try. Let's see what that looks like. So I'm going to run it, and we've got something moving. Now, looks like I don't have a rigid body translation. Looks like I get some stretching going on, but I'm going to suggest that we go back and turn on our edge colors. See what's happening. We'll run that again. There, I've made all the edge colors white. Okay, again, a little hard to see, but my edge colors are just overriding each other. So here's what I want to do. I need to, every time I go to do my plot, just before I do my plot, I need to clear the axis, because the patch command is not clearing, it's leaving this stuff on top. So just before I patch, I need to do my clear. Oops. Try this one more time. There we go. So now I'm getting a nice clean translation. You know, if I want it faster, I could either make a larger delta X, I could slow my patch, my pause speed down, do different options to play with the speed. You see the idea. Let's say I wanted to, just for fun, move both in the X and the Y, but I'm going to have them, I just want to have a single loop here, so I've got to have them tied. So let's say I'm going to have it move in the X by dx, and in the Y, or in the Z, let's say I'm going to have it move in the Z by the same amount dx. Let's say this dx, twice that dx. So it should move over and then up, but moving up twice as fast. So there's moving in the X and Y. And you can play with this all the time. Oh, now that looks like it's skewing, but it's actually just going outside of my workspace. Now we're ready for a rotation. Let's go back and eliminate that Z move. Now we're ready for the rotation. We're going to rotate the rocks around the Z. So so for theta Z equals 0. Let's go step size of, we'll go in degrees, a single degree, by a total of 90 degrees. And let's just let Z be in radians because it's expecting radians, so I'm multiplying by this little parameter DTR. That's a conversion from degrees to radians. I don't think I defined it, so I'm going to go do it up above. So there, I've defined it. Now, what do I need to do? I need to do the same exact thing. Actually, so close that I'm going to take the liberties of copying. So next, I want to rotate each vertice, okay? And I'll do that, but I'm going to have to go through all my vertices. I'm going to have an updated vertice. It's going to go from the previous vertice. Now, and I need to take the previous vertex and I need to multiply it. Now, why don't we agree that we'll update at the end of this previous rotation, we'll update the box. So we'll rotate about the new position. So we'll say box sub O, or I could just add in that I think I want it actually, now that I've done that. I think what we'll do is we'll include first the translation. Okay, so we're going to first let's get your current position, and we had it's not dx, but it's 10. Dx would end at 10, but it's by 10. Then we're going to do the rotation. So here we're going to apply the rotation, and we have to apply the rotation by pre-multiplying by a rotation operator, R. And this is our rotation that projects us from the it projects us from the new frame back to the old frame. So we want to go, or from the new frame back to the old frame. But we want to do that multiplication. Let's up above define that rotation operator. So R is going to be defined as cos theta Z negative sine theta Z 0. I'm going to do it all in one row. Sine theta Z cos theta Z 0. And I said one row, but I meant typed on one row. So I'm using semicolons to make it a 3 by 3. And then the last row will be 0, 0, 0, or 0, 0, 1. That's the rotation around the Z. Now, that is a 3 by 3. Here I'm multiplying. Here I'm multiplying by a 3 by a 1 by 3. So I need to take the transpose of that. So I'm going to pre-multiply R by the transpose of this thing. But once I'm done, I'll get a 3 by 1. So I'm going to have to go back and then take the transpose of the entire thing again. So I've got to do 2 transposes. Because that's the order in which that's given to me. And this projection will take me from the current to the new, or from the new to the current. So, or from the current to back to the original. So apply the rotation each time I'm applying it to that original set. Oh, excuse me. Yeah. So here I've agreed that we're going to first take our original vertices and move them to this new position, 10 out. And so I'll operate on that operation, or I'll operate on that new translated body. And now I can draw the box. Okay. And then I end my rotation. So let's give this a try. So I first have the translation. Then I move out here and I have the rotation. So let's, for fun, run that again. And I can see I get a 90-degree rotation. And then the last comment is, let's see if we can look at it from the top. I think top view might be view 2. This is going to change our, by the way, this is going to change our view on us all of a sudden. Yeah. Okay. This view is helpful. So I can see a couple things. One thing you can see is we translated, from our zero position, we first did a translation and then we rotated around that zero position. Now let's say we wanted to translate out, but then rotate around that new body. Well, in that case, we've got to rotate, we're going to be rotating around whatever origin set we have. So to do that, okay, so that worked fine, but the question is how to define it. Now I want to define it where I translate out to this position 10. Now I'm going to rotate around my new Z. If that's the case, I need to change the order of my operations. I need to first do the rotation and then do the translation. Okay, so I'm going to first do the rotation. So I'm always rotating from my zero guy. And then I'm going to do the translation. And to do the translation, I'm just going to add these coordinates in, okay? So frankly, we can just add this guy right up here. Apply rotation first, then translation. Now you could have made it in 2 lines, but I just made it in 1. So first apply the translation, the rotation, then the translation. So I'll run this thing. So we see it translating out. And then rotating around. It moved out of our box, but rotating around the rotating around its corner. So what it's doing is it's rotating around the point that we called the original 0, 0, 0 point there to the semicolons. Let's see what happens if we look at it in the 3 view. Yeah, and we're moving off our screen because we went from the Y and the 0, 0. So it looks like we're rotating around. It looks like our origin is the 0, 0. So to wrap this up, let's just clarify that. I'm going to go back and patch the box in the original configuration. Here it is. And yeah, see, so you can see that the 0, 0, 0 is right along the middle face. So, right there's the 0. The 0, 0 is right here. So that's what it's going to, this axis is what it's going to rotate about. if I want to rotate about this corner, I have to first translate the box such that this corner, this corner, that's what I'm rotating about, that's got to lie along this 0. I got to have it x, y, 0. I think this is the z coming up this way. So I've got to have the coordinates of that corner be x0, y0, and then z coming up. Right now, I'm rotating around the x0, y0, z coming up, which happens to be the middle of the box. So again, if I want to do just a rotation on the corner, I'd have to first translate it to here, then rotate, and then do the final rotation, translation. My recommendation, if you want to do that, is to up above do the translation so that you move the corner to that new 0 location before we define this box 0. Then with that in its spot, define this box 0 right here with that 0, 0 in the corner that you're expecting, if you will, a frame, body fixed frame attached to the corner of that box, and then do rotations like that. Okay, that concludes our animation demo.